Good night. Yours truly, Professor Dr. Dolphy Gilpin. I've returned to continue with the periodic table of elements. We have completed the first 20 and some random popular and chosen elements. And here we are continuing from 21 upwards. This is another level of chemistry. And so we have titanium and 21 and 22 is titanium. And 21 is, look like scandium. Scandium. But anyway, we are doing scotium before we do scandium, so we are doing 22. That is more reachable here. So let's go to a pack here and try to select our 22. In fact, 21 comes up before 22. But 22 notes is a little bit off. It's down the road, so we'll do 22 first. But this is 21. So we'll take it out and have it tangible right there. And let's try to get 22 now. And 22 is right here as well. So 22, titanium. Atomic number 22, atomic mass 47.90. We go to our notes for titanium. And we see a titanium, atomic number 22, atomic mass 47.9867, which would be approximately 90 to the 2 decimal point. And with a noble gas configuration of AR 3D2 4S2. And we have it here as a very reactive element, a very reactive metal. It's in the transition metal there. That burns in normal here. Melting is possible only as an inert, in an inert atmosphere or vacuum. Not 550 degrees centigrade or 1022 degrees Fahrenheit. It reacts with chlorine. It also reacts with other halogens and absorb hydrogens. No, dilute hydrofluoric acid. It reacts with halogens and other and absorb halogens like dilute hydrofluoric acid to form complex titanium ions, like a TiF6 bracket 3 minus. That is a complex titanium fluoric sort of acid with an F6 to it and plus hydrogen. It also reacts with hot hydrochloric acid to form titanium 3 complexes. It is non-reactive with bases. Bases are like alcohols, metal plus some hydroxyl like sodium hydroxide and all of that, magnesium hydroxide and all of that. Anything that hydroxyl, that's called a base. It's non-reactive with bases. No titanium compound reacts with water. Like a titanium compound, for example, would be titanium trichloride. And if it reacts with water, it will give now titanium oxide plus hydrogen. Well, that's not that reaction here. It will react with water. So titanium chloride will react with water. And the titanium itself plus 2 water in the gaseous form, that might be steam, then it will give rise to titanium oxide plus hydrogen. Well, titanium only reacts with water after the protective layer of titanium oxide is exposed. And the layer is destroyed. The titanium oxide surface layer is destroyed. It is therefore water insoluble. Titanium compounds are generally not soluble. Example, titanium carbide or titanium oxide or titanium chloride. It's generally not soluble. I'm talking about in water. And it's unlike magnesium, it is not a dietary requisite, although it has biological properties, and in that it will help grains to, it will alter the growth of grain in the soil. It's a biological property, but it's not a dietary requirement as compared to calcium or magnesium or potassium or sodium per se. All of these are dietary requirements, and if we are deficient, we'll have certain deficient malignancy, like for sodium it will be hyponatremia, and for excess it will be hypernatremia. It will be hypokalemia and hyperkalemia for deficiency and excess of potassium. It will be hypercalcemia and hypocalcemia for deficiency and excess of calcium, and hypermagnetism and hypomagnetism for deficiency and excess of, the deficiency will be hypomagnetism and the excess will be hypermagnetism. So those metals are dietary requirements, but titanium is not a dietary requirement, although you'll find small amount of it in bodies, really, and it has a biological property. It helps grains to grow. No, it is stably normal here, but when heated, it will burn with a colorful flame to form titanium oxide. And little dust of titanium in the hair particles will burn with a colorful flame. And with titanium plus oxygen, it will give you titanium oxide. This titanium oxide form a sort of a dense film. And so if the titanium oxide come in contact with water, then it has to, the surface of that titanium oxide has to be exposed, and then it reacts with the water to give you titanium compounds there, releasing hydrogen. Now, most guns and some guns and bullets are made from titanium, and titanium will form bulletproof vests, and it will not bullets will not penetrate titanium. The bullets from some gun, its bulletproof properties allows it to be used in the military, and it's also used to make spacecraft, using automobile and airspace. Spontaneous combustion of exposed layer of titanium oxide to oxygen will yield like a very aggressive reaction and ignition. So that if you have titanium oxide and it is exposed, then it will aggressively react with oxygen of the air to give you a vigorous reaction with ignition. And as, again, we say titanium alloys are used in planes, in naval ships, and in missiles and in spacecraft. So some of the uses of titanium. And the disadvantages of titanium is that above 400 degrees centigrade, it starts to lose its strength with the alloys and things like that. So that is a disadvantage, and therefore magnesium and manganese and other metal would work better after 400 degrees centigrade. Some reaction, titanium 4 chloride, TiCl4 plus water will yield titanium oxide plus hydrochloric acid, or hydrogen chloride. So we have TiCl4 plus H2O yield TiO2 plus HCl. TiCl4 plus magnesium would use titanium plus 2 magnesium chloride. So there we have a displacement of titanium from a titanium chloride or tetrachloride. It has 4 chlorides on it. TiCl4 plus 2 magnesium yield titanium plus 2 magnesium chloride. And 3 titanium plus now 2 nitrogen molecules will yield titanium nitride, Ti3N4. How would you describe Ti3N4? Probably titanium tetranitride or titanium nitride. That's 4 nitrogen and 3 titanium. Anyway, those are some of the reaction of titanium and some of the properties. I'm going to disadvantages and the uses of titanium, and that titanium with atomic number 22 and atomic mass of 47.90 with noble gas configuration of 3D2 4s2